This video is going to be about solving equations and preserving equality. So let's say that I was given an operation. Let's say it happened to be add 5. How would I go about doing the opposite of that? How would I undo that operation? Well, the opposite of addition is subtraction. So if I start off with any number, let's say 20. If I have the number 20, and I add 5, the way to undo that is to subtract 5. What if I was going to try to undo subtract 13? What operation undoes subtraction? Well, addition undoes subtraction, so I would add 13 to undo it. Dividing by 7? Well, what's the opposite? What's the inverse? Inverse is the correct word for that. What's the inverse of division? Multiplication. So instead of dividing by 7, I would multiply by 7. What if I'm multiplying by 11? What's the inverse of multiplication? Division. And I'd want to divide by the same number I multiplied, so I would divide by 11. This is how we undo an operation. We go backwards. Here we took 5 steps forward, so then we took 5 steps back. Here we took 5 steps backwards, so then we took 5 steps forward to end up in the same spot that we were before. You undo operations done to variables in the same way that you do to numbers. So before I said pick any number, and it was 20. Plus 5. And to undo that, we subtract 5. Some kind of number, that's a 5. We can do the same thing with a variable. So if I say we start with x and we add 5 to x, how do I undo adding 5 to x? I subtract 5 away. So if we have these situations here, what would we do to get back to x? For example, in number 1, it says x minus 7, but we want to get right back to x. So if I take 7 away from x, the way to get back to the number x is to add 7. Over here, t divided by 3, if I split t into 3 groups, then the way to undo that and get right back to the amount I had before is to multiply by 3. Letter C, n times 4, the inverse of multiplication is division. I would divide by 4. X plus 5, the inverse of addition is subtraction. So I would subtract 5 away. So, to add 3 to 4, I would write 4 plus 3, because that's adding 3 on to the original number 4. What would I write to add 3 to x? Well, I would start off with x, and then I would add 3 to it. That's what was done to the variable. We started off with x, or some number, and then we added 3 to it. How would we undo that? Well, the inverse of addition is subtraction. So I would subtract 3 away. So over in letter A, there is no sign between the number and the variable. No sign means multiplication. So if I have 3 times x to equal 12, I know that 3x's equal 12. I want to know what just 1x means, which means I'm going to divide by 3 on this side. But if I divide by 3 on one side, I also have to divide by 3 on the other side. So then I would just be left with x equals 4. And that balance is still kept because I did the same thing to both sides. Don't forget that the fraction bar means division. So in letter B, x plus 3 equals 12. Well, we've added 3 onto x. We need to get rid of that 3. So I'm going to subtract 3 away. And if I subtract 3 from one side, I have to do the same to the other side. So I'm going to subtract 3 over here. I'm just left with x here, and on this side, 12 minus 3 is 9. For letter C, x divided by 3 equals 5. Well, if I'm dividing by 3, the inverse of that is to multiply by 3. So I'm going to multiply by 3 on both sides. That's just x over here. X equals 15. For my last one, x minus 3 equals 5. The inverse, the opposite operation of subtraction is addition. So I would add 3. And then I have 5 plus 3 on this side. I don't know why that equal sign got put there so early, but it's gone now. Which means on this side we have x. And on the other side, 5 plus 3 is 8. Now, you might be wondering, Ms. Kovacs, how do I know I'm right in all of this? For each one of these, we can take the problem, and instead of x, we can put in what x equals. X equals 4, so instead of saying 3 times x, I'm going to say 3 times 4. Does 3 times 4 equal 12? Yes, it does. Let's double check letter B. X plus 3 equals 12. Well, I don't want x plus 3. Instead of the x, I'm going to put the number 9. Does 9 plus 3 equal 12? Yes, it does. So we're good to go. If I have x or something divided by 3 equals 5, we said x equals 15. So I'm going to put a 15 here instead of the letter x. Does 15 divided by 3 equal 5? Absolutely it does. We're good to go there. And for our last one, we had something minus 3 equals 5. Excuse me. Now, I want to know if I put an 8 here, does 8 minus 3 equal 5? Yes, it does. We're good to go. So let's go ahead and try over here to see what we would have to do to get back to the original number. Letter A says 5 minus x, do something, equals 5. What can I do to 5 minus x to make that answer back to 5? Well, I subtracted x here, so on this side I'm going to add x. Take a look at the other ones and see if you can figure out what we would need to do to each one. Pause the video, and when you come back, we'll talk about it. Welcome back. Letter B says 4 equals 4 minus t, and then we have to do something to this problem to get back to just the number 4. Well, we took t away. We don't know how much t is, but we know that we took it away. So to fix it, we're going to put t back into the problem. We're going to add t back in. What do we do for letter C? 9 minus z, do something to get 9 back? Well, we subtracted z, so we're going to add z. Same thing over here. 8 minus x, we have to do something to get back to 8, so we're going to add x back in. You can also do this with decimals. I'm going to let you guys take a look at these. If you want to try them, oops, excuse me, you are welcome to. But for the most part, we are good to go, and I hope that you have a wonderful day.